Oh, Sheila has a small doubt. Light travels straight or not? What do you think about it? Could you please put it in the chat box? Hello, budding charms. Welcome back to a rapid recap session on the topic called light. So please pay attention throughout the class and try to take down the important points. Not only that, if you find any kind of doubts in between, please don't hesitate to ask your doubts in the comment box. So I will be here to help you out. So let's get started. My name is Aishwarya Sindhu Ramachandran and I will be a science educator today. So let's dive into our contents. So we will be starting with the very first concept, a rectilinear propagation, object types, reflection, mirror types, lenses, and finally dispersion. So these are the basic concepts that we will be learning today. Oh, Sheila has a small doubt. Light travels straight or not? What do you think about it? Could you please put it in the chat box? Okay, so let me tell you, it's a very, very simple one. Light always travels in straight lines. So that is what the reason we call it as a rectilinear propagation. So light travels in a straight line and this is called as rectilinear propagation. So when you look at this, you can see that from sun to earth, the light has to travel, right? So how is it possible? It's only possible through rectilinear propagation. And now we are moving towards the next one. It's all about types of objects. So objects are mainly classified into three based on how light is actually passing through it. So let's take three of them: transparent, opaque, and translucent. So what is meant by transparent object? Oh, glass is a perfect example for it, right? So glass is a perfect example for a transparent one. Why? Because when I try to pour some water into the glass, I will be able to see how it is filling up, right? So that means it is making the light to pass through it completely. So glass is a perfect example for transparent one. What about opaque? The light cannot pass through it. Wood is a perfect example for it. What about translucent one? The light passes through it partially. That means light passes through it partially. Oh, so what is the example for it? Frosted glass, butter paper, all of these are considered as various examples for translucent ones. I hope you're clear. Shall we move on to the next one? Yes. So now we are going to talk about reflection. Oh, so that's a very important concept. Let me break it down for you. So whenever you get ready for the school, you need to look into the mirror and see how you look like, right? But why you're able to see your image there? It's because of the reflection, right? Whether your hair has been tied properly or not, whether your uniforms are neat or not, you want to check that, right? So if you want to check that, you want to see into a plain mirror so that you will be able to see your image. That's how you actually make a decision of going out, right? Yes. So here we are going to talk about reflection. So when a light ray falls on a surface, okay, it can be a rough surface, it can be a smooth surface, it can be any type of surface where the light ray falls and once it strikes, it bounces off back to the same medium. So that is called reflection. Very, very important. Take down the notes. The light ray falls on the surface, it bounces off back to the same medium and therefore this can be called it as reflection. But when you talk about the types of reflection, we have mainly two types: regular reflection and irregular reflection. Don't worry, I will definitely let you know how they are different from one another. So now we are going to learn reflection in detail. Very, very important. So I told you that we have a surface here, right? So mirror is a surface that we have considered, okay? And there is a light ray which is falling onto the surface. So this is called incident ray. I can call it as IR. And make sure that there is a proper arrow has been given. Otherwise, the whole diagram goes wrong. So now the incident ray falls onto the surface at a point called POI, point of incidence. Very important. And from point of incidence, it bounces off back to the same medium as reflected ray. So this is reflected ray. Look at the arrow here. This is how it be turned on. So this is reflected ray. This is how the arrow has been shown here. An imaginary line which is perpendicular to the surface itself. Oh, this is called normal. So I can represent it as N. So you can say that incident ray, normal, reflected ray, all of these are very, very important when you want to learn reflection. And now I'm going to tell you an important thing. So this is nothing but the angle between them. How they're different? Let me tell you. So for that I'm using a different color. So the angle between incident ray and the normal can be called it as angle of incidence. Clear? Similarly, the angle between reflected ray and the normal can be called it as angle of reflection. In this particular phenomena, you can see that there is something very important happens. What is that? Angle of incidence, which is equal to angle of reflection. You always need to remember this particular point. Okay? So now we are moving towards the next one, and look at this. Regular reflection and irregular reflection. How they're different from one another? Let me tell you. So the first one is regular reflection. So this happens from a very smooth surface. Look at it. It's a highly polished surface. And what about the image? Therefore, the image is going to be very clear and sharp. So let's take an example here. So the reflection on a plane mirror, which creates a very sharp image. If you want to see your own image in a plane mirror, oh, that's going to be really perfect if it is really polished, right? Yes. Why? Because it is going to create a clear image because of the regular reflection happens there. Clear? And when you look at the reflected rays here, so I'm going to add some arrows. Okay, so these are the incident rays and these are the reflected rays. And look at the reflected rays here. They are parallel to each other, right? Yes. So the reflected rays are going to be parallel to each other in case of regular reflection. What about irregular reflection? This occurs on a rough surface. So then what happens? Look at these. The reflected rays are not parallel at all. So the reflected rays are not parallel. At the same time, the image is going to be blurry, or sometimes no image will be formed at all. So what is an example here? Reflection of water which creates an irregular shaped moon. So reflection on water which creates an irregular shaped moon. So this is a perfect example for it, and that's all about it. And we are moving towards the next one. It's all about laws of reflection. Whatever the type of reflection is, whether it is regular or irregular, the reflection must happen just by obeying laws of reflection, right? So laws of reflection is nothing but a key to all type of reflections. Whatever the type of reflection is, it needs to obey laws of reflection for sure. So that is what we are going to learn now, and it is basically two statements. What are they? The first statement is almost clear to us. The angle of incidence is equal to angle of reflection. This is the representation for it. Okay. And what about the next one? It's very, very important. The incident ray, reflected ray and the normal at the point of incidence all lie in the same plane. Oh, so this is a point of incidence. Okay. This is an incident ray. This is a reflected ray. This is a normal. And all same plane. Oh, how is it possible? So I'm going to take a plane like this. So I'm considering a vertical plane where all of these things are lying on. Clear? So this is all we have explained in the second statement of laws of reflection. So please don't get confused. And now we are moving towards the next one. It's all about images. So images are of two types. What are they? Real images and virtual images. What is meant by a real image? These are basically formed due to the actual convergence of light rays. So here the light rays are actually converging, and therefore this can be seen on a screen. Real images can be seen on a screen. But what about a virtual image? These are formed due to the apparent convergence of diverging light rays. Or you can say that they never meet each other. Okay, the light rays never meet each other, and this is basically due to the apparent convergence of divergent light rays. Very, very important. So you can say that virtual images cannot be getting on a screen. Okay, these are very, very important. And now we are moving towards mirrors. So there are mainly two types of mirrors: plane mirrors and spherical mirrors. So these are the two types of mirrors that we need to learn here. So we are moving towards the next one. Look at it. It's all about image formed on a plane mirror. So we all know what is a plane mirror, right? Whenever you want to get ready for school, you need to look at a particular mirror where you can see your own image, right? So that is nothing but your plane mirror. And now we are going to talk about the characteristics of image formed on a plane mirror. The first one is erect. What is meant by erect image? It is upright. It's not upside down. It is always upright. Okay? And same size. What is meant by that? If Arun has a height of 150 centimeter, then Arun's image is also going to have 150 centimeter. And virtual. That means it cannot be taken on a screen for sure. And what about lateral inversion? Oh, that's an amazing phenomenon in which if you raise your left hand, it shows as right hand. And if you raise your right hand, the image will be shown as left hand. So this is nothing but lateral inversion. And object distance is equal to image distance. How is it possible? Let me break it down for you. Let this be the mirror. Okay? And here you can see that this is an object and this is an image. Okay? So the distance between object and mirror, let's take an example of 3 meters. Okay? So what would be the distance between image and the mirror then? It's going to be same. Okay? So this is also going to be the same distance, 3 meters. Clear? Got it? I hope everyone is clear with the concept, and now we are moving towards spherical mirrors. Very important. So when you look at this, we have two types of spherical mirrors, concave and convex. So concave mirror is also known as converging mirror. Please don't get confused. Concave mirror is also known as converging mirror. The inner surface of the curved mirror is reflecting here. Okay, so that you can call it as a concave one. So where do we use this? We use it as dental mirrors. And what about the convex one? Convex one is known as diverging mirror. So the outer surface of the curved mirror is reflecting. So example can be vigilance mirror. You might have seen this particular mirror placed on roads, right? Yes. So that's all about spherical mirrors. And now we are going to talk about refraction, a different phenomenon. Reflection and refraction, both are different. Please don't get confused. So here we are going to learn about refraction. So here we are going to talk about refraction. So what is meant by refraction? For that, there are two media which are required. So let this be the first medium, medium 1, and let this be the medium 2, M2. Okay, so we have two media here in which light actually travels from one medium to another so that the bending could happen. Oh, amazing, right? Yes. So the bending of light, when light ray moves from one medium to another, can be called it as refraction. So that what happens? The speed of light definitely changes. Got it? And now we are moving towards lenses. Oh, in that itself, we have two types. What are they? Concave and convex. But here you have to be very specific. Why? Because concave is known as diverging lens, which is basically used to correct myopia. What is myopia? Short sight. Okay, so if you want to correct myopia, you can make use of concave lenses. What about convex? This is known as converging lens. It is basically used to correct hypermetropia. What is meant by that? Hypermetropia is far-sightedness. That means long sight. Okay, so now we are moving towards dispersion. Oh, it's an interesting phenomena in which when white light passes through a prism, what happens? It splits into 7 component colors. Oh, that's how you're able to see rainbow, right? On sky, we don't have any kind of prisms, but instead we have tiny water droplets. So when white light or sunlight passes through these water droplets, dispersion occurs, and therefore you will be able to see a beautiful rainbow with 7 colors. So what are the different colors? Vibgyor, okay? Violet, indigo, blue, green, yellow, orange, and red. Got it? So this phenomena can be called it as dispersion. Okay, so now we have finished almost all the concepts of the particular chapter. So rectilinear propagation, object types, reflection, mirror types, lenses, dispersion. Oh my God, we finished everything, and I hope everyone liked it. And that's all about today's session. So let's get back with an amazing session similar to this. Have a nice day and goodbye everyone. Thank you so much.